Hey everyone, it's Magnetics. Today we'll be taking apart this Logitech G402 gaming mouse. We're going to be taking it apart to see what goes into making them and also review it from an engineering perspective. If you haven't already, please go ahead and like and subscribe. It really helps a lot. So, let's go ahead and get started. So I've accumulated a few mice over the years. This first one is a Key Idea gaming mouse. It's about $15 on Amazon. I think it's actually gone now. Now we have the Logitech G402, which we'll be taking apart today. Really like it a lot. I use it for quite some time. And then right now I've been using the Razer Naga Trinity with the removable numpad on the side. Definitely love it a lot. Definitely worth the money. If you can get your hands on it, go for it. So this gaming mouse I used for the better part of a year. One thing I noticed is that I was gripping it really tightly, so I ended up switching to the Naga Trinity just to have a more looser grip on a mouse. These foot pads were an absolute pain to take off, and if you ever do take those off, I would suggest replacing them with ceramic foot pads because they really don't adhere back well onto the mouse and really cause for it not to be smooth on your mouse pad anymore. I was really surprised by how many screws were actually in this mouse. I think that was part of the reason I underestimated exactly the amount of engineering that went into making these things. But once you get all those off, it actually pulls apart really nicely. And it actually looks super clean, both inside and out. Very well designed, just right off the bat. It kind of shocked me how nice it was, how well it's made. So now I'm taking off the PCB. One thing I noticed is that they actually put one PCB on top of another. That was pretty impressive, and the fact that they have like 8 buttons on this mouse really requires them to be really creative with their engineering. Once I finally got all those off, I was like, what is going on under here? And then I realized there's a wired channel actually running from the PCB and out. I thought that was some pretty nice little detail that they added there, that it wasn't just right there. They actually did some engineering. I don't know PCBs too well, but this one was definitely probably one of the most dense I had ever seen. The fact that it has 8 buttons on there and there's a lot of system work that goes into this, that was pretty cool. Also, this little optical piece was actually very well made. Exactly where the laser actually comes through was very well polished, and I was kind of just blown away by the quality of that. This was also designed very well as well. One thing I was extremely disappointed by was the back. As an engineer, I like to keep things really simple, but these ribs on the back really just add cost. They really don't add anything to it, and also it's the underside of the mouse. There's no value to the user there. So I was really disappointed to see that, but I guess that's also kind of the show and the flair of Logitech and big companies showing what they can do. So now for the actual mouse body itself. There were so many screws here, I was actually sort of intimidated when I first opened it up. But after a while, I was actually able to get all of them through. Um, I kind of got lost at one point. It definitely was hard to see with the lighting I had, so I'll put on a different light a little bit later in the video to take a look. And there it is. So once I finally got all those out, I had to figure out how this was actually deconstructed. And one thing I also noticed is that the light for the G was actually caused by a stem that actually goes back down to the PCB. So actually kind of a nice little piece of engineering there, really smart. Not something I would think of right off the bat, but definitely someone who's working on plastics would recognize here and there from time to time. So kind of impressive. And also one thing they did is they made 3 pieces actually bend around one screw. Imagine the thought process that goes into that. The engineer just looking at that and being like, oh wow, we have to affect 3 pieces for this one screw. But they did it and it worked out well. Trying to take this apart now kind of stumped me a little bit, but finally I ended up figuring out that this part was sort of clipped around the end, which I thought was pretty impressive. They didn't really have to make it one piece, but they did. So just kind of showing off at that point. Took me a few minutes to get off just to make sure I didn't break anything, and I want to use this mouse again. So there's a stem for the light again that you can see sticking down. I'm guessing that that's an insert molded piece. And so for this next portion, I see that there's a few screws for the actual mouse click buttons. And once I undid those, I realized that those were both separate pieces. So that was pretty cool. One thing I didn't even notice when I was using this mouse is that these pieces are actually offset a bit, so the mouse isn't just like symmetrical. They're actually offset a little bit. So that was pretty cool to see from that perspective and that viewpoint while I was doing this. So once I got those off, I realized, okay, now I need to take apart like all these buttons, which is going to be an absolute nightmare. So unfortunately, this took me longer than I'm willing to admit. So I sped up the footage a bit, so that way to kind of disguise how long it actually took me to get these out. Basically, they were just not a lot of space for them to wiggle around, which is great. Awesome engineering, awesome design, but really made for sort of a headache for me. So eventually, I was finally able to get those out, which was great. Pretty impressive pieces. They're very interesting, a lot of curvature, a lot of stuff built into them. Was able to take the rest of the pieces out, and just overall was kind of blown away by how they were making the buttons. And then I also got stuck on the DPI indicator button, which is basically a light that just shows what DPI you're on. And it was basically kind of crammed in there, not a lot of tolerance to wiggle around, which again is a good thing. But again, it took longer than I'm really willing to admit here. Eventually, I got those out and could take apart the rest of the mouse and kind of move on with the video. Pretty cool tiny little pieces though. Very impressed by how tiny these were, but with how many there were, I was also very surprised. And it also sort of helped me understand why like that cost is justified. While there are some things that are a bit superfluous here, um, really the tooling and the amount of investment they're making to make these things really makes the case for them charging a higher price for them. Specifically for this mouse is about like $50, $60, sometimes up to 70 depending where you buy it from. So really justified, and I can definitely see, coming from a cost engineering perspective, why they might be that expensive. You think of the Naga Trinity as well, you're going to see similar things. And the plastic molding on this was amazing. The part I'm holding right now is one piece, and there's different finishes, there's different size holes, there's even, the threads are actually threaded. It's not like they just molded a hole and then screwed something into it. They actually put threaded inserts in there to make sure that it basically closed well, and that if you were to take it apart or it was going to be repaired, that you could do it easily and that it wouldn't get destroyed. Also, I don't know who does this, but the flex of these materials was extremely impressive. The fact that they could test this and make sure that it's going to move in the same way that you would expect, and the nice feel of it, is pretty cool. I just couldn't get over how well made these parts were. Definitely someone who has a lot of experience with plastic molding parts, and also who does similar things maybe in terms of like keyboards, other computer parts. Definitely spent a lot of time on this, and they invested a lot of money on whatever team of engineers was actually creating this. Logitech has a bunch of other mice that they make, and all of them are extremely high quality. One thing I did notice here is that these little I-beams on this part, that's exactly what's interfacing with the button. So they're actually making, another feature to make sure that there's good contact with the button that's being pressed. So just another little tiny feature that they're making an investment on. So now putting this back together was a pain, and I will admit, but I won't show it, that I actually had to take it apart again about halfway through because I missed a screw. So that's basically cut out of here. But it took me a little bit just to get it through. And the reason why it took me so long is because the tolerances are so tight. Basically, with your fingers, it's really hard to put everything together. But if you're a trained individual, you've been doing this you're doing this every day, assembling this by hand, you're going to have a better time than I would. I was basically just kind of winging it at this point. So finally got those tiny little pieces back in. Took a little bit of doing, but the real doozy was those two pieces that are in the top left of the mouse. Those were the DPI buttons, and those were just so fickle. There was basically like a corner and edge that they like didn't fit in. So sped this up to sort of hide how long it actually took me, but yeah, it took me a while, which is really unfortunate. So finally, once I got all those together, I felt pretty happy, and I was actually extremely impressed by how the whole process went and how everything was put together. Now it's basically time to put the rest of the stuff on. So I got putting the mouse buttons back on was actually a bigger pain than I thought it would be. You actually had to put the feature that contacts the actual PCB button in first and then sort of flick it around the little stanchions that it sits on and what it's screwed into. So, bit of a little puzzle there, but once I figured it out, it was pretty straightforward. There are a lot of screws here. I almost lost a few of them. I can't tell you how many I dropped like by accident while I was doing this, so I'm glad I actually ended up with all of them again. Putting this piece back on was a lot easier than it was to take out. Basically, you just had to clip it around the side and then clip it through, and now there you go. It's all set, and you're good to go. So now I had to put back all those screws. I think I counted about 16 screws in total, if I remember correctly. That's quite a lot, and some of the other mice I've taken apart in the past have had maybe, I don't know, 10. So this was sort of surprising and a bit of a puzzle for me to solve, which is kind of fun. And it really goes to show that they're actually taking a lot of time and engineering and investing a lot of money for this. This is a really good design. It's really reliable. It's not going to wear out. And even I could tell how some of the parts were molded and engineered. These are going to last for a while. They made sure that they're robust enough, they're thick enough, and that the portions contacting some of the buttons aren't going to wear out. And the fact that like the mouse button you think is like so long, when in reality it looks so small when you're looking at it. But the reason why it's so long is to prevent wear out. And I think, if I remember correctly, this mouse specifically boasted that you would get about 1 million clicks out of it before any potential performance issues happened. So once I finally got back together, I was extremely happy to see that the light went back on and it worked again. I'm sort of worried about breaking the mouse. Yeah, thanks for your time and thanks for spending it with me. I hope you guys got something out of it and have a good rest of the day.